Okay, so the last concept with word problems that we're going to talk about is DRT problems, which stands for distant, rate, and time word problems. Now, these types of word problems are very famous in jokes. For example, there's a comic on my door right now that says Mathphobic's Nightmare. And it's a picture of an angel standing outside the gates of heaven and a guy standing out there who clearly just died and is now trying to get into heaven. And the angel is standing there and he's got a clipboard and he is saying, okay, now listen up. Nobody gets in here without answering the following question. A train leaves Philadelphia at 1 p.m. It's traveling at 65 miles per hour. Another train leaves Denver at 4 o'clock. Say, you need some paper? So this particular comic is the type of problem I'm actually going to teach you how to do today. So you could say that I'm trying to get you into heaven, if you'd like. All right, so to start off, I'm pretty sure if you're in 8th grade and you've learned about distance, rate, and time, then you probably know that to calculate distance is equal to somebody's rate times their time. So at the top of your paper, let's just write that equation. The equation is D equals rate times time. So D equals RT. That's going to be really helpful when we do these problems. Now, when we do these problems, it's really important that we understand how to fill out these charts. So in your chart, you're going to have a description, you're going to write something about a rate, you're going to write something about time, and then the distance is always going to be your rate times your time to get somebody's distance. So I'll summarize at the end how to do the chart after we do a couple problems. So let's just take a look at number 1. So number 1 says, Mary leaves her house at 2 p.m., traveling at 45 miles per hour. Later, her brother Joe leaves and travels in the same direction at 60 miles per hour. If Joe leaves at 4 p.m., what time will he catch up with Mary? All right, so now we are not going to worry about the question at all, like right now. We're going to worry about the question at the very end. What we're going to do now is we're going to fill out all the things that we know. For description is we're going to talk about who we're talking about, right? So we're talking about Mary and Joe. So let's say we've got Mary and Joe. And now, do we know something about Mary's rate? Yes, Mary's rate is 45 miles per hour. So rate is always measured in miles per hour, feet per second, inches per minute, something like that, right? So that's a rate. So Mary is 45. So I'm just going to put 45 in for rate here. And then it says later, her brother Joe leaves and travels in the same direction at 60 miles per hour. So Joe's rate is 60. All right, now, time. You may look at time and say, okay, well, time, Mary leaves at 2 p.m., but that's not what goes here. Time is going to be how long Mary travels or how long Joe travels, right? Well, we don't know. It does not say that Mary traveled for 5 hours or Joe traveled for 6 hours, right? But what we do know is we know that Mary left at 2 p.m., and we know that Joe left at 4 p.m. So if you think about it, we don't know how long Mary's been traveling. So let's call Mary X. And so Mary's going to be X. And now think about it. Mary's been traveling. She left first, right? She left at 2 p.m. She is traveling. And then Joe leaves at 4 p.m. Well, what's the difference there? The difference there is 2 hours. So Joe's traveling is X minus 2. Now let's think about why is it subtraction? Well, it's subtraction because Mary has been traveling for those 2 hours and Joe did not travel those 2 hours. So Joe is actually traveling 2 hours less than Mary because he left later. You could write Joe as X, and if you write Joe as X, then Mary is going to be X plus 2. Okay, so there are 2 ways to write this. All right, so now, distance. The distance column is always, what I want here is distance of Mary. Well, Mary her rate is 45, her time is X. Well, we get the distance column by doing rate times time equals the distance. So Mary's distance is 45x. All right, Joe's distance is going to be 60 times x minus 2. And so we're going to say 60, and the x minus 2 has to go in parentheses, or you can go ahead and distribute it and make it 60x minus 120. Okay, now that you have the chart filled out, when you have the chart filled out, this last column, the distance column, is going to be what's going to help us write our equation, okay? So no other part of the chart helps us write our equation, just the distance column. And you always get the distance column by doing the rate times the time. All right, so now let's just get a picture of what's happening here, okay? So down here, I'm gonna draw this little picture. Here's the house. Mary, she left the house at 2 p.m. And she's traveling some distance in some direction. And what we know is that her distance can be calculated by 45x. This is the expression that represents her distance, meaning that the x is how much time she's traveling for, and she's going 45 miles per hour, so it's 45 times x. Then we have Joe. Joe left 2 hours later at 4 p.m., and he's going in the same direction, and his distance is measured by multiplying 60 times x minus 2. Now, because he's going faster, he's going to eventually catch up with Mary. And by the time they catch up, what's going to be true about their distances is that their distances are going to be equal. Because they're going in the same direction, they left from the same place, they're going to have covered the same amount of distance by the time they meet up. And that right there is our clue for our equation. So our equation is going to be that Mary's distance, 45x, will equal Joe's distance, 60 times x minus 2. And now when I solve this equation for x, well, that is going to give us Mary's time. And then we'll be able, once we have that, we'll be able to answer this question. We'll also be able to answer all these other questions down here. So once you've set up your equation, then you solve for x. And so I'm going to distribute the x, or the 60, and you get 45x equals 60x minus 120. And then collect your variables. So we're going to subtract 60x from both sides. And we're going to get negative 15x equals negative 120. Then we're going to divide everything by negative 15. And you're going to get that x is equal to 8. All right, so now it's important that we understand what x represents. So that's what we have this chart for. X is representing Mary's time. Now this again is not the time of day. This time is measured in hours. How do I know it's hours? Well, I know the hours because I know the rate is being measured by miles per hour, right? If the rate was being measured in feet per second, then the time would represent seconds, right? But in this case, it's hours. So X represents that Mary travels for 8 hours. Then it says, let's read all the questions. So what time will he catch up with Mary? Let's get to that question in just a second. Let's just answer all these questions. So how long was Joe driving? Well, Joe was driving x minus 2. So since x is 8, well, 8 minus 2 is 6. So Joe is traveling for 6 hours. How long was Mary driving? Well, that would be 8 hours because Mary is being represented by x. This question, if I said, how far did Mary drive? Well, that's Mary's distance. Well, Mary's distance is right here. Mary's distance is 45x. So that would be 45 times x, which is 45 times 8, which is going to be 360 miles. Whoops, pen. 360 miles. And now how do I know it's miles? Well, I know it's miles, again, because my rate is being measured in miles per hour. So that means the distance is miles and the time is hours. It all depends on the rate, what we're measuring here. Now, how far did Joe drive? Well, Joe, he drove this expression 60 times x minus 2. Now, if we did the problem right, it should be 360. So let's just think about this. If I put 8 in for x, 8 minus 2 is 6, and 6 times 60 is 360. So Joe also drove 360 miles. And then the question, what time did they meet? So this is actually the question that we're trying to answer. I was just answering these other questions to show you how to use your chart to answer any kind of question that I give you. So what time did they meet? Well, what time did they meet? There's two ways to figure this out. You can start by saying, well, Mary, she left her house at 2 p.m. and Mary traveled for 8 hours. So if she left her house at 2 p.m. and traveled for 8 hours, well, what's 8 hours after 2 p.m.? That would be 10 p.m. So the answer to the question is they met at 10 p.m. That's when they caught up. That's when Joe caught up with Mary. If you also could look at the time Joe left at 4 p.m. And Joe, well, he traveled for 6 hours. And isn't 4 p.m. plus 6 hours also 10 p.m.? So this is the answer to the question, that they will meet at 10 p.m. All right, so that was a lot for one question, which is why we're going to do several more. So let's look at the next one.
All right, second scenario.
We've got here Jane and Peter. They leave their home now traveling in opposite directions on a straight road. Peter drives 15 miles per hour faster than Jane. After 3 hours, they are 225 miles apart. How many miles did they each drive? So we're not going to worry about the question right now. What we're going to do is we're going to worry about filling out this chart. So the description, who are we talking about? Jane and Peter. So let's write in Jane and Peter. And then let's read what's happening. So they leave their home, they're traveling in opposite directions. I'm just going to kind of visualize this. So they're traveling now in opposite directions, okay, on a straight road. Peter drives 15 miles per hour faster than Jane. So this does not tell us how fast they are driving, but it gives us a comparison. So Peter's the faster driver. So if I call Jane X, then that would mean that Peter is X plus 15. If you called Peter X, then Jane would be X minus 15. Okay? Then it says after 3 hours, they are 225 miles apart. Well, the 3 hours right there, that's how long they've both been in their car or traveling on whatever vehicle they're traveling in. Both of them have been traveling for 3 hours. But they're going in opposite directions. Now, don't let this 225 miles apart mess you up, because does it say here that Jane is going 225 miles or Peter is going 225 miles? No. This is their combined distance. The distance column is always the rate times the time, because this has to represent Jane's distance. So Jane's distance is going to be X times 3, which is better written as 3X. Peter's distance is going to be X plus 15 times 3. So it's 3, and then in parentheses, X plus 15. Now, in this case, it does not say that they're going in the same direction. They're going in opposite directions. So I want you to picture this. If this side is Jane, and Jane's distance is being represented by 3x, and this over here is Peter, and his distance is being represented by 3 times x plus 15, well, their combined distance together is 225 miles apart. So like they're going in opposite directions, and then they're driving away from each other, so their combined distances is 225. So in this particular case for the equation, their distances are not equal, right? If you think about it, Peter is going to cover more ground in 3 hours than Jane is because he's going faster, right? But we know that they're 225 miles apart, so we're going to add their distances together. So it's going to be 3x plus 3 times x plus 15, and you can distribute that 3 if you want to start with, equals 225, because that's our combined distance. Then we're going to solve for x. We've got to solve for x in order to answer the question to begin with. So distribute the 3, and you're going to get 3x plus 45 equals 225. Combine your like terms. 3x and 3x are on the same side of the equal sign, so that becomes 6x plus 45 equals 225.
and then solve for x. So subtract 45 from both sides. 225 divided by 45 is 180. So then you get 6x equals 180. Then we're going to divide by 6. And 180 divided by 6 is 30. So you get here that x is equal to 30. So now let's think about what does x mean. We look at our chart. X is Jane's rate. So Jane traveled for her rate is 30 miles per hour. But that's not the question. It says, how many miles did they each drive? So that's asking about their distance. So Jane, she drove a distance of 3 times x. So since x is 30, Jane is going to be 3 times 30, which is 90 miles. And then Peter, his distance is going to be 3 times x plus 15. So that's going to be 30 plus 15. So we would just do 30 plus 15, which is 45, times 3. And that's going to give me 135 miles. And so Peter traveled for 135 miles. This right here is the answer to the question. Jane traveled 90 miles, Peter traveled 135 miles, and the way to quickly check it is we said that together they traveled 225. So if you add 90 plus 135 together, you should get 225, and I do.
So those are the two basic problems that you're going to have. You're always, when you have these problems, going to fill out that chart. So let's just summarize what we're going to end up putting in that chart every single time we do a problem like this.
All right, so whenever you get one of these charts, the description is always going to be what we're talking about, right? There's going to be two things moving in these problems, right? So some examples here about what the description would be kind of what we've written, right? Like, so here, I'll come up with two different examples. So it could be like train 1 and train 2, right? We could have two different trains happening, okay? We could have two people, like Joe and Bob, or we could have you're taking a plane ride. You're going to a place, and then you're coming home, so that would be like to and from, right? It could be two different places. You're going to Alabama, and then you're traveling from Alabama to some other place, right? So it could be that. The rate is always measured with a unit rate. So for example, miles per hour is the most common. You could have feet per second, right? What if you're measuring how fast a bug is moving, right? That could be in feet per second. You could have inches per millisecond or something like that. So that is always going to be a rate, right? And you have some options, right? Sometimes you just might be given the rate, right? I could be given 10 miles per hour and 30 miles per hour. Or the rate might not be given and you have to use a variable, right? So I could have like x and like x plus 15, right? Time is not time on a clock. So I want you to write that. Not time on a clock. Time is measured in hours, seconds, minutes, right? Always. All right, so now time, suppose you're given the rate. Time could be measured with a variable, right? So like suppose I have like x and x minus 3. It's going to be minus for whoever's traveling the least amount of time, okay? Or you could have x plus 3, okay? Or you could be actually given some time. I could say, you've been traveling for 8 hours. Both people have been traveling for 8 hours. Or train 1 has been traveling for 8 hours and train 2 has been traveling for 7 hours, okay? But time is always measured in hours, seconds, minutes. It's not the time on the clock. And then this last column, you are always, always, always doing the rate times the time of each person, place, thing, train, to, from, whatever. So here, it's always going to be the rate times the time from what you have in the beginning of the chart. So the whole kind of point of filling out the beginning of the chart is so that we can get an expression for the distance. Okay? Now, once you have the chart filled out, you're always going to use the distance column for your equation. Okay? Are the distances equal, or do you have a total distance? So times when your distances, you'd set your distances equal, is like in the first two examples where you have two people leaving at different times, going in the same direction, and they're meeting up. And look, when I drew those two arrows, it's kind of like an equal sign. Another example would be if, let's say, you're doing a round trip, right? You're going some distance and then you're coming home, right? Still, you go somewhere and you come back, still looks like an equal sign. Those are some examples of when your distances are the same. Then the other type of equation is where you take your two distances, distance 1 and distance 2, and you have a total distance. The total distant ones will be like ones where you're in opposite places and you're traveling towards each other. You're going to be given another distance in the problem that's a total. That would be where you add the distances together. Or in like the last example, traveling somewhere where you're going someplace in town and then you're getting on the interstate and you're continuing, right? You have two different rates, two different distances, two different things going on, but you're going in the same direction. That's one other way. Another way would be if you're traveling, if there's two different people or objects traveling in opposite directions and you're given a total distance, that would be another time where you're adding the distances together. So hopefully this whole chart right here will help you figure out how to set up your equations.
If you feel like you need some more examples, if you continue watching the video, there are a few more examples at the end of this video that will help you. If you feel good about it, you can go ahead and stop. Good luck. So here is one more example about the Hill family.
The Hill family and the Platter family are going on a road trip. The Hills left 3 hours before the Platters, but the Platters drive an average of 15 miles per hour faster. If it takes the Platter family 13 hours to catch up with the Hill family, how fast are the Hills driving? So we're talking about two families, right? So we were talking about the Hills and the Platter family. So let's type in my description, would be Hills and the Platter family. And then let's just see what we know about these guys. So we're trying to figure out if we know their rate, something about their rate, and something about their time, how long they've been traveling, not the time of day. Okay, so the Hills left 3 hours before the Platters, but the Platters drive an average of 15 miles per hour faster. And then it says it takes the Platter family 13 hours to catch up with the Hill family. So right there, in the Platter family takes 13 hours, we know that the Platters, they traveled for 13 hours. So right there, the Platters' time is 13. So now the Hills left 3 hours before the Platters. So think about this. If the Hills left first, are they traveling more time or less time than the Platters? Well, they're traveling more time because they left first. They left before. So they are actually going to be traveling for 16 hours. Okay? Now, the thing we don't actually know their rate. We know that the Platters drive 15 miles per hour faster, so let's call the Hills X and the Platters X plus 15. Now you could switch it up. You could call the platter's x, but then the hills would be x minus 15 because they're 15 miles per hour slower. I like to keep things positive. So there's always two ways to come up with your variable expression. So now, distance. This column is always rate times the time because this distance column is representing the hill's distance. And you can get the hill's distance by multiplying your rate and time together. So x times 16 is going to be represented with 16x. And then the platters are going to be 13 times x plus 15. And if you feel like distributing that 13 to the 15 to start with, you're allowed to do that. Okay? So now it says that they're on a road trip, and it sounds to me like they're going in the same direction because the platter family is going to catch up with the hill family. So same scenario we had before. We've got the hill family. They left. Their distance is being measured by 16x. Then we've got the platter family. They left. Their distance is being measured by 13 times x plus 15. And they're going to meet up. And once they meet up, their distances will be equal. So my equation again, I'm going to solve 16x equals 13 times x plus 15. So when you do these problems, the equation, you're always going to do something with the distance column. So this column is going to be how we come up with our equation. So now let's go ahead and solve the equation. You're going to distribute the 13, and that's going to give you 16x equals 13x. 13 times 15 is 195. Collect your variables to one side of the equal sign. So I'm going to subtract 13x from both sides. That's going to give me 3x equals 195. Then we're going to divide both sides by 3. And you're going to get that x is equal to 65. So now in this case, well, what does that 65 represent? Well, that's why we have this cool chart. This chart, here's your x. The x represents the hill's rate. So the hills traveled for 65 miles per hour. I know it's miles per hour because the rate here is miles per hour. We're talking about hours, and the problem as well. So read the question again. It says, how fast are the hills driving? Well, that's the answer that I got here, right? Hills rate 16 miles per hour, or 65 miles per hour. So the answer to the question is the hills are driving 65 miles per hour. Now, I could ask you several questions. If I asked you how fast were the platters driving, well, the platters are being represented by x plus 15. So you'd put 65 here. You just add 65 and 15, right? If I asked you how far they traveled, well, you would plug in the x for the 65 in here for x and do 16 times 65, and you get the same thing if you plugged in 65 here because their distances are the same because they're going the same direction and they meet up. Okay. Let's try some new scenarios. So for this next one, go ahead and read through it a few times and see if you can come up with the description, the rate, the time, and the distance, and then tune back in. So stop the video, read it, try the chart on your own. So here we go. We have Heidi and her sister, and it says they are currently 20 miles apart. That is not each person's distance. They are currently 20 miles apart. They begin to head towards each other at 8 a.m. Now, remember, 8 a.m. is not the time we put here. I put in two x's because they both left at 8 a.m. and they're traveling towards each other. All right, and they're 20 miles apart. Heidi is snowmobiling at a rate of 20 miles per hour, so that's where the 20 came from, and her sister is cross-country skiing at 10 miles per hour. What time did they meet, and how far did each sister travel? So before we answer this question, let's come up with the equation, and the equation is always going to be done with the distance column. So if you think about it, this one says that they're going towards each other. And how far apart are they? So they're in two different places. So let's say Heidi is here and her sister is here, and they are a total distance away from each other. They're 20 miles per hour. They're 20 miles away from each other. So their combined distances is 20 miles. Well, Heidi's distance is being represented by 20x, and her sister's distance is being represented by 10x. And Heidi's going to cover more distance than her sister because she's going faster. Just something to think about. So this is another one where to the equation, you're going to add your two distances together. So it's 20x plus 10x equals 20 miles. So now I'm going to go ahead and combine my like terms. 20x and 10x is 30x equals 20. And then I'm going to divide both sides by 30. And this should not freak you out because you are going to get a fraction. You're going to get x equals, well, 20 over 30 reduces to 2/3. Well, let's think about what that means. Well, the x means that that's how long they were traveling. Well, what does x stand for? X stands for time, which is in hours. And I know it's in hours because my rate is being measured in miles per hour. So, what time do they meet? Well, let's think about this. The x stands for 2/3 of an hour. So we need to think about this is not a whole hour. So 2/3 of an hour is how many minutes? Well, you got to think. 2/3 of an hour is 2/3 of 60. So 2/3 of 60 is just doing 2/3 times 60 over 1, right? 3 goes into 60 20 times, and 2 times 20 is 40. So these girls are traveling for 40 minutes. And what time? The question up here, what time did they meet? Well, what time did they meet? Well, if they left at 8 a.m., right here it says they left at 8 a.m., they traveled for 40 minutes, they met at 8:40 a.m., and then the next question is how far did each sister travel? Well, the distances are here, right? So Heidi traveled for 20 times 2/3. So 20 times 2/3 is going to give you 40 over 3. And now we need to actually come up with a number for that. So 40 over 3, 3 goes into 40 how many times? It goes in 13 times, and that's a third. 13 1/3 miles is how far Heidi traveled, and then her sister would be 10 times 2/3. So I'm going to do that over here, would be 10 times 2/3, and so that's 20 over 3, and 20 over 3 would be 6 2/3. 6 2/3. So the answer to the question is 3 things. They met at 8:40 a.m. Heidi traveled 13 1/3 miles, and her sister, I should write sister here, traveled 6 2/3 miles. One way to check to see that your distances are correct is that you know that they were 20 miles apart, so their combined distances should equal 20. Well, isn't 13 1/3 plus 6 2/3? That does give me 20. Okay, so hopefully you've started to notice that the equations can be set up 2 different ways. You're either going to set your distances equal to each other, or you're going to add them to equal another distance. So maybe you're starting to see a pattern. Go ahead right now, stop the video, try number 5 completely on your own, see if you can get it, and then tune back in. Okay, so this one, don't be confused. It's not Bill and his friend. It's Bill's going to see a friend, and his friend lives 225 miles away. He drove to a town at an average of 30 miles per hour. So it's in town and on the interstate are my 2 things. So in town, he was 30 miles per hour. On the interstate, he was 70 miles per hour. And then the trip took 3.5 hours total. So that means this is kind of tricky and a little bit hard to think about. The times, it doesn't say that each thing took 3.5 hours. It's that these 2 things together have to equal 3.5 hours. So think about just we don't know how long they were in town. We don't know how long he was on the interstate. But we do know that when I add these 2 together, it has to equal 3.5. And so if I have the town as X, then this one could be 3.5 minus X, right? Because it's 3.5 hours total, so whatever it was in town, you subtract. And
it doesn't matter if you switch these. You could make the town 3.5 minus x and the interstate x. In the end, whatever you solve for is whatever you have the x as is what you're going to plug into these expressions to get that. So that's a little bit tricky to think about, but this is what you get for the times. So then if you have this set up like me, this would be 30x, and then this would be 70 times 3.5 minus x. You could have the 3.5 minus x up here and the x down here. Okay, so now let's get a visual. The visual for this is that he's taking a trip. So he's driving around in town, and his distance in town is represented by 30x. And then he gets on the interstate, he's driving on the interstate, and that distance is 70 times 3.5 minus x. The combined distance, like his friend, is 225 miles away. So this is another example where you're going to add the two distances to get 225. So I'm going to do 30x plus, I'm going to go ahead and distribute right now. 70 times 3.5 is 245. So I'm going to distribute the 70. So I'm going to get 245 minus 70x equals 225. And so all I did to get that last little bit is I just distribute the 70 to the 3.5 and the x. So now let's combine my like terms, and I'm going to get 30x minus 70x, which is going to give me negative 40x plus 245 equals 225. So now let's solve for x. So I'm going to subtract 245. And 225 minus 245 is negative 20. So I have negative 40x equals negative 20. And then I'm going to divide both sides by negative 40. And I'm going to get that x is equal to, well, that reduces to 2/4, which is 1/2. So x is equal to 1/2. So let's go back and answer the question. The question is, how far did Bill drive on the interstate? So Bill drove on the interstate. This is his distance. So you're going to put 1/2 into x. So I'm basically going to do 70 times 3.5 minus 1/2. Well, 3.5 minus 1/2 is just 3, so it's just 70 times 3, and 70 times 3 is 210 miles. And that's the answer to the question, right? Had I asked how long was he in town, well, how long he was in town is x, so that would be 1/2. How long was he on the interstate? Well, that would be 3 hours, because 3.5 minus x is 1/2. If I said how far did he travel in town, that would be 30 times 1/2. Okay, so you're just using your chart to answer whatever the question is. All right, so now let's summarize what we just did.